Jai Hind all. This is Assistant Professor Gagandeep Singh from Ajay Kumar Garg Engineering College, EC Department. This is a lecture series on complex topics of satellite communication. And in this topic, we are discussing a network architecture of VSAT. This VSAT we have discussed in the third unit, which is fourth unit, which is basically the application of the satellite communication. VSAT is very small aperture terminals or the small antenna stations. We will discuss the network architecture, or you can say that the OSI model for the network of the VSAT. So first of all, we will discuss the VSAT basics, and then we will discuss how the network architecture is defined in OSI model. So VSAT we have discussed also that it is a very small aperture antenna or very small aperture terminal, which has a size usually lesser than the 30 meters. So this 30 meter is a small, if it is a the antenna size or terminal size of the earth station is lesser than 30 meters, it is called the very small aperture antenna. This is required first of all to make the end user the application an accessible application. This affordable application is possible only when we have a higher power transmitted as well as the higher frequencies. When we increase the frequency, the size of the antenna will decrease. As a result, we can get a very small aperture antenna. So this will result in a smaller aperture antenna at the earth station. So this this gives a difference between the two stations. One is the larger antenna system, second is the smaller antenna system. A wavelength of 100 watt is 100 wavelength is called the difference between the small and the large antennas. A feedback which is getting a Cassegrain feedback is to have be at least 10 tenths of the wavelength for its subreflections. This break point of 100 watt below this one, the terminal will be smaller one. So this is called the small aperture antennas or small aperture terminals. With the smaller antenna, one consideration is that we have to have a tighter link budget, because with the higher frequency, even though we have advantage of smaller terminal, but with this higher frequency we will have more attenuation of rain as well as all other atmospheric attenuation. So as a result, we have a very less margin for the link budget. So we will have to make a tighter link budget. So small antennas are typically for the C band, which is a higher frequency or our required frequencies, below which there is a 500 meter or lesser size of the antennas. So this is a standard VSAT antenna or small antenna. This is generally used for VSAT or USATs, mainly used for the DTHs and mobile service stations. So VSAT system, generally it underlies the objective of VSAT system is that to bring all the services directly from the satellite to the end user without having any intermediate of MSC or BSCs, etc. So by doing this, we can reduce the hierarchy of the all distributed network. For example, we can have a without all the overheads cost of the MSC and BSC in the mobile station will be reduced by using a satellite mobile phone. This will, so obviously this will also reduce the distribution cost, because only one satellite is communicating with the all other earth stations. So all other technologies can be leapfrog for this technology VSAT system, which can such as WLL, wireless local loop. Wireless local loop can be seen as the intermediate between the satellite and the end user. So if we say the wireless local loop, the VSAT when collaborate with wireless local loop, telecommunication is using these two systems. So telecommunication in the developing nations, mobile phones and the all other systems of the telecommunication phone systems are basically backbone for the development. So when WLL is already available, we can use VSATs for the distribution links of the community for the satellites. Using existing wireless loops with the VSAT can be one of the solutions. So second thing is that geostationary satellites are required to be used for the link a large number of VSATs with the main switching center, which can be a WLL or a BSS or MSC. Each VSAT acts as a local switching center for any local region, for example, in villages or a rural community. With the final end user of the telephony link being carried over the wireless local loop. So there is a link between WLL center to the satellite, which is using the VSAT, and then WLL to the user, which will be using the telephonic link for the communication. For example, this is an example given. We have a satellite which is for example, this is an example of use of WLL for the VSAT communication. Here is a satellite which is transmitting a signal from an earth station. This earth station is transmitting signal to the satellite, and satellite is giving this information to the VSAT and the WLL terminals. This is an tower which is carrying VSAT. This VSAT with the WLL communicates with the all other applications. For example, for a village, for DTH or TV services, this is communicating with the VSAT of this station, and then public telephone, payphones, which is again communicating with VSAT for the satellite services uses. Then there is some farms which is using GPS and all other collaborative applications for the satellite. So all these are using VSAT for the communication. So this WLL with VSAT gives the user density dependency. As you said, the economic basically for the developing countries, the economical advantage of the VSAT solution is required, and this solution is dependent upon the number of users. As the number of users will increase, the growth of the economy will be there. So physical distance, major transportation routes, and the geographical barriers, as well as the individual countries' demographic politics can alter the breakpoints between the low VSATs and the small satellites and the large aperture satellite terminals. So mainly this VSAT is used for the last mile problems, the areas where we have difficulty to reach, then reliability, then time to deploy because it is easy to deploy, then the flexibility and the cost. Now VLSC user density dependency can be seen from here, where we are using even for a user between very small areas, between few kilometers, we are using only some of the local or the terrestrial networks. Then when the area is increasing to the number of users are increasing with the per kilometer, we have to use VSAT with VLSS, which gives the accessibility of the application with the increased number of users. Then for the higher user, for the more number of users, we need fiber optics as well as the other other microwave technologies for the communications, because of the delay that is associated with the VSAT and the satellite communication. So all these breakpoints are generally dependent upon the demography and the policies of the countries. So implementation can be done in three ways. One is the one way in which VSAT is communicating with the users only. So the implementation of VSAT services can be done in three ways. One is the one-way implementation, in which VSAT is communicating with the end users only. For example, in the TV broadcasting, VSAT is broadcasting the signals to the all users only. Second is the split two-way, whereas one is transmitting at a one time. However, both can be transmit user as well as the VSAT. But however, one is transmitting only at the one time. For example, one time VSAT is transmitting, then user cannot transmit the signal. Second case, when user is transmitting, then VSAT cannot transmit. Third is that two-way implementation, where we have uplink and downlink, both can communicate at the same time. The implementation of VSAT in architecture, in the structure, is the two-way. One is in the star topology, and other is the mesh topology or mesh way. In the star topology, central hub is communicating with all the other VSATs. For example, in the previous example, where we have one VSAT and all other users are communicating with that VSAT, is the one example of the satellite, of the star topologies in the satellite. So this hub can be a satellite which can communicate with all other hubs. Here the propagation delay is higher because of the central hub has a much more load to handle. So all these VSATs is handled by the hub. So propagation delay is difficult. Here, one user is transmitting is using TDMA. It takes a time slot for the transmission. It takes a time slot for the transmission. When the slot of this VSAT comes, it transmits only at that time. So at the central hub, we need a high investment because of its capabilities. We need a higher capability VSATs which can handle a large traffic as well as a low, which has a high reliability. Smaller VSAT antenna size is required, can be used because only one hub is communicating with all the VSATs. We can target we can directionalize the antenna toward the VSAT or toward the hub. Second is the lower VSAT cost, because VSAT has to communicate with the only one hub. So the overall cost of this VSAT will be lower. Second is ideally suited for the interactive data applications, where we need a central hub that can communicate with VSAT can communicate with the all other hubs. Large organizations like banks, centralized data processing equipments are required, where we need security also. Second is the mesh topology, in which one VSAT is communicating with the all other VSATs. So every VSAT here, this VSAT is communicating with the all other VSATs. This VSAT is communicating with the all other. So this is also communicating with the all other. This is also communicating with the all. This is also communicating with all, and this is also communicating with all. So each VSAT is connected with the all other VSAT in a network. So here propagation delay is lesser because of because they are communicating directly without having any intermediate between the two VSATs. Here we use demand access, multiple access, where the user or VSAT has to assess the medium by raising a demand. Here there is no central hub, so investment for that one is very low. However, the VSAT size, antenna size will be higher, so higher cost of the VSAT will be there. The cost of or the larger size is because the directionality of this antenna will be more. So this is generally used for the high data traffic, where we have a high data traffic, so hub cannot handle it single-handedly. So we need to distribute all the data. That is, this makes this topology suitable for the implementation. For example, telephonic application as the point-to-point high speed links. So in the network, we can say that there is a star topology, there is a central hub or station. If anything is to be communicated with any other VSAT, that is communicated first of all the hub, then it is communicating to the other next VSAT. So this is called the double hoop link in the VSAT or in the satellite. Since all the traffic is through the one hub only, this architecture is also known as the star network. This is one example of star network, where satellite is a central hub and all other VSATs are communicating with this central hub. So this VSAT 1 can communicate with VSAT 2 using the satellite link only. This is the block diagram of the star topology. Their VSATs are there, and any hub or a station can communicate the satellite to the all other VSATs. Then there is a mesh topology, where network has the ability to communicate directly with all other VSATs. Since the traffic can go from any VSAT to the other VSAT, this is called the mesh network. It is also necessary to control the network duty of the hubs either by the one of the VSAT, which is called the master control station, or it can be distributed about the all VSATs. So this is also increasing the functionality of the VSATs. So this is again a network where satellite is there, which is communicating, but this VSATs are also communicating with each other. So this type of network will be the mesh network. So here a number of VSATs are there, and here a number of VSATs are there, and each VSAT can communicate through a link, or it can be communicating to the other links. The topology of a mesh network from satellite's perspective, note that how the VSATs are communicating directly to each other without passing through the large master control VSAT. So ISO has given some specific protocols for or OSI model for the 7-layer stack. The conceptual model for satellite link occupies a physical layer, which is the transport layer or the VSATs. This VSAT network must have terminal controlled each end of the link. The network control center is responsible for the remaining layers. So if we go with the OSI layer, it is application layer, presentation layer, session, transport, network, data link layer, and the physical layer. These 7 link layers are the for the OSI model for a general network. But for the satellite communication, we have one problem, which is the delay. To mitigate that delay, we have incorporated this OSI has incorporated this gateway. So inside a user which is using the TCP model or OSI model, this user, when transmits signal to the VSAT, VSATs communicates in the two parts. One is the physical layer, interface layer, and protocol layer. Then network layer network layer kernel is connected through this gateway. So this gateway is using this VSAT. This VSAT is communicating with a hub. This hub station again have a network kernel and protocol interface and physical interface for the communication between the users. This gateway is connecting the hub station. This physical interface is communicated for the layer 2 for layer of the user and user. So in this way, this protocol is there for the OSI layers are changing for the for the VSAT network. Basically, design consideration for the VSAT is if we use a TCOM 507, this creates a link budget, multiple access as well as modulation scheme for the VSAT. Then we have some frequency allocations consideration for this one. For example, for the fixed satellite services, frequencies are allocated like C band, which is 4 by 6 by 4 or 4 by 6 gigahertz, then Ku band 14 by 11 gigahertz, and then Ka band, which is 30 by 20 gigahertz, and is using commonly. And for the smaller antenna, we have already said that we have to have a small sensitivity, and that is why we have smaller G by T ratio. So in this way, we are using a number of users for the VSAT. To increase the number of users, we use spread spectrum technology, which is generally CDMA. So this is all about the VSAT. Here we have discussed what is VSAT and how it is communicating, and how VSAT is using the communication terminals. Then we have discussed the topologies, that network architecture, how the different VSATs are connected with the hub, and at the end we have discussed the OSI layer model for the VSAT. Here we have discussed the hub and the VSAT architecture, which is a 3 plus 1 plus 1 for the gateway, 1 for the network, and 3 for the interface protocol and the link layers. So this is all about the VSAT topology. Thank you.